call for May 20th, 2026. As always, we will be posting the recording of this call on the Reed Cohort YouTube channel within a few days. And the presentation will also be available in the Reed Cohort Google Drive library. We'll kick things off with a couple of announcements. The one that I have is the availability of a really good two-page document, frequently asked questions about the transition of the REAF qualification, REAF, Resource Advisor, Fireline, into the 310-1 NWCG position catalog. That's a big change that happened back in January. Lots of folks have questions about it and how it pertains to their particular situation, where they are in their journey as a REAF, REED, ARC, or REEC. And the good folks of the Resource Advisor Subcommittee at NWCG have put out a two-page FAQ document. I posted it in the chat earlier, and I'll post it in the link to it in the chat again. There we go. Jess beat me to it, and I appreciate that. Really does, in my mind, a solid job of addressing some of the questions, particularly for folks who may be in a trainee status or who may have fire training officers who have some questions about it. Anyways, let me kick it over to Lynn. I believe you've got an announcement, Lynn.
Yeah, I just wanted to tell everybody, I did just notice that it's no longer in our monthly email, so we'll get it back in there next month. But anybody with the old emails, there is the link to the read reef requests and spreadsheet that you can get to. It's in the Google Drive in that folder. I have been getting not a great number, but occasionally a request for editor access to that spreadsheet. We don't give out editor access to that spreadsheet. There's only a couple people that have that because we've had problems with getting wrong phone numbers, wrong people who aren't actually associated with the fires, putting in requests for fires. So but there are directions on how to use it and who to contact in order to use it. And we'll get the link out again, and I'll put it in the chat too. But if you are a lead read or an agency administrator or a bureau manager under the new definitions, you feel free to contact the cohort, and we can get those requests into that spreadsheet, and people can take a look at it for when they're looking for an assignment. But that's all I got.
So Lynn, just to kind of underscore, this is the spreadsheet for incidents looking for help, right? Incidents looking for resource advisor, archaeologist type help.
Yes, correct.
Perfect. Any other of the managers or anybody else have any announcements before we move over to our main topic today? All right, not seeing any hands. So got a great one, folks. Closing the line, monitoring fire line repair effectiveness. And without further ado, I'll kick it over to LUCA ADELFIO with thanks for this being LUCA's idea, and him being willing to do the legwork to get it from that, hey, we should talk about this, to actually, hey, we are going to talk about this and have a great presentation. So with that, thanks, LUCA.
Yeah, thanks, Pete, and thanks everyone for joining. This is, I think, a great topic for all resource advisors, and I'm excited that Sarah Lewis-Scholes has been willing to come and present to us and share some quantitative research. These are kind of a first look at preliminary results from an ongoing study, so happy she's willing to share with us. And then afterwards, I think the presentation will allow time for question and answer. So I'm going to be, if you throw your questions in the chat, I will start kind of collating those, organizing them as we go, and at the end we'll have a question and answer session, both from the chat and, of course, folks are welcome to raise their hands. But I'm here to learn just like the rest of you, really excited to hear about it. And I believe first we have MARISA Anderson providing us with a little leader's intent from the post-fire program, and hopefully a good introduction of Sarah, who's a real heavy hitter in the post-fire space with hydraulic modeling and all sorts of other really cool tools. Their lab in general is so focused on practitioner tools, stuff that we can use in the field, and so I see this kind of as an extension of that great work. So thanks, MARISA, and thanks in advance, Sarah, and please throw your questions in the chat all, and I will get them organized for the Q&A. Thank you.
Thank you. Hi, MARISA Anderson. I'm an ecologist in the Intermountain region based in Ogden, Utah. And I am Dave Callery's proxy today. He was going to kick this off, but he has to do a in-person field training at the moment. So I have some information to relay from him. So this effort started, I think, a few years ago. I think even Lynn Gasway was trying to get this going, and both Dave Callery and Kara Sponagel, they are part of the Forest Service's Washington office, and they're in the post-fire group. And they approached Rocky Mountain Research and also Fire and Aviation Management to try to get some real quantitative data on some of the different types of suppression repair that we do. And it's really been a grassroots effort from resource advisors. We know how important suppression repair is. We're getting more and more lines every year with larger fires, and if they're looking at larger big box contingency containment, everything kind of just keeps growing in size. And also our repair methods have been evolving a bit over the years as well. Back in the day, we used to do a lot of water bars. I think a lot of us aren't doing those anymore as much. We have a lot of variability with different vegetation types and soil types and precip regimens. So it's really important to try to get a pulse on, what types of techniques work where, and hopefully some of this research can help us. We also try to encourage folks to do some of their own monitoring in their backyard, and depending on how formal or informal you can do it, it's good to go back and look to see what techniques were done in your backyard and what's recovered, how's it looking like. So we really encourage everyone to be able to go back and look post-fire, go back a few years to see how the repair is going. Let's see. I think that's all I have for you. And so Sarah is going to take it from here and talk about some of the studies that they've done. So thank you for all that. Thanks, Sarah. Go ahead.
Thanks, MARISA and LUCA, for those nice introductions. I'm going to share my presentation here. There we go. All right, yeah. Like MARISA said, I am Sarah Lewis-Scholes. I'm an engineer with the Rocky Mountain Research Station, part of Forest Service Research and Development, based in Moscow, Idaho. A couple of my colleagues who are integral in this project but couldn't be here today, Scott Shepard and Pete Robichaux. Some of you may know them. MARISA and I chatted briefly a couple of days ago, and I was really pleased to hear that this wasn't a top-down ask. It wasn't just Dave and Kara asking us to do this research. It was much more of a bottom-up. It was the Reeds and the Reefs, the resource advisors, who wanted to know about the effectiveness of these Fireline repair techniques. So I will just jump right in, get you started with our research. This is really pretty hot off the press. We got
our annual report turned into Dave and Kara just a couple of weeks ago. We were out in the field into November of last year collecting data. So, you know, the fires are burning late into the fall, and then the repair goes on even beyond that. And then by the time you get a research team out there, site selected, research gathered, etc., we were out there all fall. So most of you on this call are resource advisors. I actually just took the Reed Reef training last week in Kamiah, Idaho. I have a little better understanding of the Reed Reef job, making recommendations for suppression repair to protect resource values, often following treatments or prescriptions from a local unit. Often there are national or legal guidelines that also need to be followed. And my understanding so far is that it's generally been a local or anecdotal evaluation of the effectiveness. There hasn't been a lot of hard science, you know, actual numbers behind the effectiveness of these treatments. You know, are they reducing runoff? Are they preventing rills from forming? Are they allowing for natural or, you know, the desirable vegetation recovery and not just invasive species recovery? Are we limiting the OHV access that we're looking for, restoring the naturalness? During the course of this project, we worked very closely with Reeds and Reefs. They were our escorts on the fire. They helped us select sites. Some of them helped us install silt fences. We had help on some of the experiments, the rainfall simulation experiments you'll see later. We really appreciate the collaboration of the Reeds and the Reefs so far in this project. We are a water and watershed science team. Like LUCA said, we have a long history of conducting post-fire experiments. My supervisor, who just retired, has 35 years in the field. I have 25 years in the field. Some of the other things we've been asked to do, we've been asked to evaluate the effectiveness of some of the bare treatments that are used, like the mulches or the seeding, like in what conditions do they work, how do they not work? And the tools that you'll see here, the silt fences, the rainfall simulation, those are some of the same techniques that we use to evaluate other, you know, instances where we might want to know the runoff or erosion after a treatment has been applied post-fire. Yeah, so like I said, the silt fences, and then we also have a rainfall simulation, so a high intensity rainfall, and then a concentrated flow. So we'll apply water just straight down a hillside and see how much infiltrates, how much runs off, if the rills form, like in that picture in the lower right over there. So far, we have looked at fire lines on 4 fires over 2 years, 2 fires in 2024 and 2 fires in 2025. So far, they've all been in Idaho and Washington within about a half-day drive of Moscow, Idaho. And by the time I get done talking about these sites, you'll probably have a pretty good idea of why we've picked sites that are so close to home. It's intensive sampling. It's, you know, crews of 6 to 10 people for a week or more at a time, revisiting these sites after heavy rainfall events, revisiting to clean out silt fences, repeating these experiments in multiple years. So it's just really it's an intensive study, and thus far we've just kind of started it close where we can have fairly easy access to these sites. So we've evaluated a spectrum of treatments, a fairly minimal treatment where just pulling in the berms and scattering available organics, some more intermediate treatments such as hand water bars, like just Pulaski water bars, larger water bars that were excavator dug, and then I think what kind of kicked this whole discussion off was a novel treatment that I've heard referred to as pocketing tater patches. I think that was Kara's, chunking, pitting, really it's the decompaction of the soil, creating roughness to slow runoff. I'm sorry if you guys are getting all these, I'm getting all kinds of notifications on my screen. I hope you're not seeing them. Anyway, so really looking at that novel treatment. Also, one of the fires was next to a logging operation, and we had a lot of available slash to scatter. So that's one of those things, right? If it's a drier site, there might not be the available organics. If it's a wetter site, you know, heavier fuels, or next to a logging or mastication operation, there might be more slash to scatter. So really, we aren't looking to manipulate the treatments as much as we want to evaluate the treatments that would organically be prescribed on a fire, right? So if one of the sites, the first one I'm going to talk about, they're like, we don't use water bars. We don't think we need water bars. And so we just looked, they pulled in the berms and scattered the slash. We looked at that as a treatment. One of the sites, large water bars were dug by an excavator, and that's just, we didn't prescribe that. That was just the treatment that was prescribed on the site. So our goal was to go to a fire, pick some sites, and evaluate the treatment that was prescribed by the local unit. The first fire we'll look at is the Lime Point fire in central Idaho on the Payette National Forest. Kind of a dry mixed conifer system, rocky, loamy soils. 77 miles of dozer Fireline on this 33,000 acre fire. There were multiple kind of inholdings, small residences within this fire. So they built a lot of fire lines, contingency fire lines to protect those sites. And on this site, we selected a silt fence study. So here are some of the example untreated lines, or the control lines. We installed 5 control silt fences and 5 treated silt fences. The ground cover in these control lines had almost 80% soil and 8% rock. So there was very little vegetation or organics on these lines without a treatment. In contrast, here are the treated lines. So the berms are pulled in, a little bit of slash scattering, almost 60% organic cover, and still quite a bit of rock and some soil available. So the design of these silt fences, these are generally just like a 1 dozer width line, and then the silt fence itself is 1 to 2 meters deep, so maybe 6-8 feet deep, and it collects any sediment that, you know, ends up in, you know, at the bottom of the hill due to rain, due to snow melt, due to, you know, other soil disturbance. And then the water is allowed to, they're permeable, so the water infiltrates through, it just collects the sediment. We also have tipping bucket rain gauges at these sites, so we're able to see the total rain that contributed to any erosion, and then like the intensity of the rain. And also we are monitoring the nearby snow-tell sites, so we have an idea of the snowpack in the area. The goal is to go back to a site after a high-intensity rainfall, or at least twice a year, once in the spring, once in the fall. The spring, the intention is to collect any sediment that was due to snow melt, and then the fall would be anything from, you know, summer or fall rainstorms. At this site, pretty low rainfall year. I think that was fairly true across most of the Northwest. Only 4 to 6 inches of rain on these sites, low snowpack. We found minimal sediment on the sites. So the sum of all 5 control fences, there was about a half of a 5-gallon bucket of sediment. Which is not very much, nothing like we maybe would have expected if there'd been some higher intensity rain on those bare soils. But for, you know, for comparison, there was about half of that on the treated sites. So probably some effect due to the pulling in of those organic materials. Maybe the more interesting piece on this fire, though, so we have a line over here on the left in the fall of 2024, right when we're installing it. Same area, the following spring. So that's also a control line, right? So nothing was done here. Up to about 50% ground cover. And then on a treated site, very close by, up to 80% cover. So really just looking at that kind of natural vegetation response when you are decompacting the soil, pulling in the berms, and just not really doing much else. There was no seeding on these sites. So pulling in, you know, kind of fluffing up that soil seemed to help a lot in this site. Another fire we went to in 2024 on the Colville Reservation in Washington. This was another dry site, had, you know, wide dozer fire lines. We initiated a silt fence and simulated rainfall concentrated flow study here. So we are actually adding water to the sites. You know, the first one I talked about, we're just entirely dependent on the natural rainfall, snowfall regime. Here, we're adding water. We are forcing erosion to see what happens. The control lines had about 35% organic cover when we started. Generally, needle cast. I think you can see the needle cast in that lower right-hand corner. So just natural needle fall, which is actually a fairly, it can be a pretty effective erosion control technique, if you will. Looking at the treated sites, what they did for treatments on this site was less of these slash scattering, and I don't think they pulled in all the berms. This was more of a water bar study. So looking at the middle photo is a hand water bar, so just a Pulaski dug water bar, and there's a silt fence at the outlet of it. So we're collecting any sediment that runs down the hill slope into the water bar and then into the silt fence. So we are testing the effectiveness of the water bar to maybe trap some of the sediment if there's any, and then looking at the, you know, these two different implementations of water bars. And you can see on the far right, I was saying that these were pretty extreme water bars, in my opinion. They are 1 to 2 meters wide, so maybe 6 feet wide, 5 or 6 feet wide. And then that 5-gallon bucket fits inside of it. So it's, you know, 2 to 3 feet deep in some areas. So they're pretty, it was quite a bit of additional soil disturbance to dig these water bars. And here, the silt fence yield, it was another dry site, or another dry year. One of the sites had a little bit more rain. And what we saw was still more sediment in the control fences. Quite a bit, still more than we saw like on the Lime Point site in the machine water bars. But look at the hand water bars. Very, very little collected on the hand water bars. And the picture on the right here, it's one of those fences on the hand water bar site. So it was a little bit wetter of a site, but maybe not having that additional disturbance of those big machine water bars, those excavator dug water bars, was the appropriate call in this situation. The results of the rainfall simulation and concentrated flow experiment, we use the same treatments, the control, the machine, and the hand water bars. Prior to the concentrated flow, you can see these tall rainfall sprinkler risers. So they spin around, deliver rainfall at about 1 inch per hour. We pre-wetted these sites until they just started to pond water on the surface. And then we added a concentrated flow, pretty much from that pink flag there. So it's about a 10-meter plot. Right at that pink flag, we release 5 different flow rates, starting at 7 liters per minute. And 1 liter is like an Nalgene water bottle, right? So 7 liters per minute. It's a pretty low flow rate going down that hill slope. But we bump it up over time to 48 liters per minute. So it's kind of a gusher by the end. We are really forcing runoff and forcing sediment erosion. Some pictures of the sites. That's what it looks like at the pre-wetting. We just wet the soils. In the middle, a picture of a runoff sample collection. We use sheet metal to collect timed grab samples. So then we know how much runoff is coming off per unit time, how much sediment is coming off per unit time, because we're not able to collect all of the sediment and runoff that come off. And on the far right, one of the sites after we have added the concentrated flow, you can see the rill has formed, some good cutting down of the soil from the runoff. Treatment comparison. I know tables are not everybody's favorite in a PowerPoint, but I highlighted what I think are the important parts. The hand water bar sites had half, not quite half of the flow rate that the control and machine water bar sites had. And they had, a quarter or less of the sediment concentration. So kind of seems like it, was probably might have been a site factor, a little bit wetter site with more organics, maybe different soil types. But then also we don't have that additional soil disturbance that we saw on those big excavator water bars. So this was the site in year 1. We did repeat this experiment in 2025 on the exact same plots. Here, different view, but this is what the site looks like 1 year later. More, you see the vegetation growing in, even on a control water bar. So nothing was done there, but lots of needle cast. We've got more vegetation coming in. And then look at the difference in sediment concentration on all 3 treatments between year 1 and year 2. We often, kind of a rule of thumb is that there's about an order of magnitude difference in sediment between year 1 and year 2. So you see that you really can, you lost a decimal place on the control and the machine water bar plots between years 1 and year 2. The site seems to be recovering. I don't think we're going to go back to this site again this year because we had such a nice reduction in values. I think we'll use our resources and go sample a different site. So conclusions from the site was maybe the site with more vegetation and also the smaller water bars had less runoff and sediment. Moving on to fires that we sampled last year, new fires in 2025, the Island Creek fire on the Nez Perce Clearwater National Forest in Idaho. Only treated 7.5 miles of Fireline on this site, but it was an interesting one because it was right next to a logging operation, like a really recent one. I think it got shut down right when they were closing the area due to the fire. The treatment prescribed was pulling in the berms and scattering the logging slash. So this is a site, or this is a photo we took when we were scouting the site. The water or the fire line goes up the left side of the photo, and then on the right side you can see the slash pile from the logging. Heavier fuels on this site, mixed conifers again. And we did a silt fence and a rainfall concentrated flow study here. This is what it looked like when we were, this is the flagging we put out. We went out with a couple of resource advisors when we were scouting, and this is how we communicate with the dozer operator, the excavator operators, where to treat and where not to treat. So put these big X's with flagging out there. We've labeled the pin flags, do not enter, leave this as a control site. This is what the sites look like as controls. So still about 50% exposed soil, but also 50% organics, just as a function of having that logging slash in the area, I think. And then the sites that were treated with a logging slash, about 90% cover, which is pretty high on the, I think that's a high treatment prescription. I don't think anybody would expect that normally. In the resource advisor training I was in last week, I think some of the guidelines they mentioned were for like putting too much slash on the site was, I think you wanted to make sure it was less than 18 inches in size, maybe less than 4 or 6 inches deep. And I don't think that these exceeded that. We had nice, provided a nice ground cover, which is what you want if you're going to add slash. You don't want to add heavy fuels to the site because you don't want any sort of reburn risk. Anyway, so these are the two treatments that we looked at on this Island Creek fire. And here's what it looks like, kind of in the middle of the experiment. We are raining on the site. We rained for 1 inch per hour for a full hour. At the halfway mark, we started adding the concentrated flow. So we're really doubling up on the amount of water that we're adding to these sites. Comparing the control on the left to the treated on the right, we had about half the flow rate on the slash treated lines, and we had about a quarter of the sediment concentration on the on the slash treated lines. So that slash really did the job, trying to slow that runoff, pond the water, didn't let the flow concentrate and end up in a big rill at the bottom of the plot, in the way that you see all the water on the surface in the control site. And another interesting piece, I know this was a question Dave really had for us last year. He wanted to know, just when we're just raining, we're not adding concentrated flow to these sites, because really the idea is that these treatments are intended to either not just reduce the concentrated flow, but maybe even prevent it. So if we just rain, don't add the flow, what happens? And on some of this, on the control sites, the average time to run off was about 12 minutes. So just with the rainfall only, it took 12 minutes to get runoff at the bottom of the plot. On the logging slash treated site, it took nearly 40 minutes for that 1 inch per hour rain to reach the bottom of the plot. So a big, big difference. And I don't know if it's typical to have a 40-minute 1 inch per hour rain in these sites. So that's, we're kind of testing some of the higher limits of it. But this would indicate that this treatment would indeed prevent that concentrated flow, or maybe even the rills from forming at all. And then on to maybe the most interesting topic that you're all here for, pockets, patches, chunking, and pitting. These are two photos that I got from LUCA. They're not my photos, but they were just kind of some examples of sites that he had seen. On the left, we have a picture from the Umatilla National Forest. It says that the excavator, his goal was to make 2-foot chunks of decompacted soil in a bit of a waffle pattern, and then spread the slash and knock down the berms on that site. So, really created some nice roughness there. And on the right, a photo from the Los Padres National Forest. And the interesting thing here was that the dozer line was created along this trail. And so the goal in the patching or the pitting was to, create a lot of roughness off of the trail to encourage the traffic just to stay on the trail and not leave it. And it looks like they accomplished that task there. So yeah, the pocketing, patching, whatever you want to call it, decompact the soil, create the roughness to slow runoff, create the pockets to collect water and sediment, and also to block that OHV, any undesired traffic on those sites. We looked at a pocketing technique on the Rock Fire, which is also in Idaho on the Boise-Payette National Forest. There were 50 miles of Fireline on this site. Partly there were residences in the area and also a ski resort, Tamarack Ski Resort, that they were trying to protect. We used a simulated rainfall and concentrated flow study here. And because this was a new treatment for us, we worked very closely with the resource advisors and also a lot of supervision of the excavator operator during the treatment install. Pete Robichaux, my supervisor, previous supervisor, he was out there with the excavator operator during the whole repair process. And he kind of told the operator what he wanted. And at first, it sounds like he was like doing these bigger patches, kind of more like what we saw in the first couple of pictures. But because this site, it's really close to the Lime Point fire, which I talked about first, that site that said, we don't really need water bars. Like we know our soils, we know our rainfall patterns. So on this site, we're looking for kind of a smaller pocketing technique where like if you don't need water bars, you probably don't need really huge pockets to slow any sort of runoff or sediment. So this is kind of what the pockets look like, about a foot deep, maybe 2 to 3 feet wide. That notebook in the middle there is just your average 6-inch right in the rain notebook. We'll see if this works. I embedded a video. I know we've all seen dozers work, but it's still kind of, or excavators work, but it's still kind of fun to see them, you know, kind of doing that fine scale pocketing work. Here are some photos on the left of what the control lines looked like. So this is our experiment set up on one of the control lines. You can see the berms, you can see the lack of vegetation cover, less than 40% organic cover, about 60% soil. In the middle, you can see that excavator digging a water bar. We did some water bars on these sites just for experiments. And then on the pocketing slash sites, almost 60% organic. So between the control and the pocketed sites, you basically can flip the organic and soil parts, right? So 40-60 on one, 60-40 on the other. But I mean, they look a lot different, but those are the mean values that we collected when we did our ground cover plots. But just the, you know, even just the additional roughness of that pocketed site compared to the smooth soils on the control site. The results of our rainfall concentrated flow experiment on the control Fireline, the 2 pictures on the far left, 25 liter per minute flow rate was what the runoff rate was, and then 122 grams per liter sediment concentration. These are higher values than we saw on the Island Creek fire, and it took 14 minutes to run off. So for the rainfall only portion of the experiment, it took 14 minutes to run off, which was similar to how long it took on the control sites on the Island Creek fire. Contrast those with the pocket treated fire lines. I highlighted a couple of the pockets after the runs, how they filled up with runoff, provided a little bit of a sediment detention pond, and that seemed to really slow down the flow rate, about half the flow rate again, and then a quarter of the sediment concentration. The time to runoff in the rainfall only portion of the experiment was 25 minutes. And you can compare that to the Island Creek fire, which had all of that slash, which took about 40 minutes to run off. So still a big difference compared to the control plots. The Island Creek fire, that slash made a pretty big difference in the time to run off. And I think that is kind of all I have here. Yeah, so some preliminary conclusions for the treatments. That pocketing reduced both runoff and sediment yields. The high slash cover also reduced runoff and sediment. In a site where maybe only a minimal treatment is needed, pulling in those berms definitely added the vegetation response. And also, I kind of want to comment on the minimalistic take. The site where we looked at the excavator water bars versus the hand water bars, the minimal treatment seemed to work there as well. How to prescribe a treatment, that expert local knowledge of soils, expected weather patterns, those are all so helpful. Do you have highly erodible soils? Are you expecting high intensity rainfall? Those large water bars may create additional soil disturbance. But if you have a high intensity rainfall regime, maybe you need those for some soil storage capacity or to slow runoff off of a high priority line. What is the vegetation density in the surrounding area? How much available slash is there? What is the seed bank in the berms? Is there a possibility of native seeding? That is one treatment that we haven't had the opportunity to look at yet, but it sounds like that might be a direction that a local unit might want to take on. And also looking at the vegetation response at a species level. I work with a bunch of hydrologists and engineers and modelers, and we are not plant people. I can give you a plant functional group. I'm not going to be able to tell you the species exactly of a plant. So knowing whether they are, invasives or undesirable species or, desirable native species, that would be, I think that's another direction that Dave and Kara are looking to go in with this project. So maybe we'll be able to work with somebody on a fire who can kind of take that part of the experiment moving forward and look at those plots over time. Maybe look at the plots that we've set up and see what the difference is between a control and a treated site. Other factors to consider: is there a logging or mastication operation? Is that slash available? Is one side of the line, was it burned out from the line? So if you're putting in water bars, you definitely want to put them, the direction of the vegetated side, not the burned side. And then access, always a consideration, trying to minimize traffic, but also, is this a line that's going to need to be reopened at some point? So what kind of future access are you looking at on these lines? We're to the question portion. Here's my contact information, and my colleague, he goes by Scott Shepard. This was a photo we all took with the water tender that we had on the Island Creek fire. We added the ash part into we used some tape and added ash. We were really pleased with our work here. But I added this picture because we have two reeds in this picture. We had Emma and Vic I think they're from the Payette on this fire, and they worked with us. They had so much fun working with us on the Rock fire that they joined us on the Island Creek fire, and we really appreciate that collaboration. Like I said early, like all these sites that we picked are within a half a day of Moscow, Idaho. But in order to expand this operation to other regions, really looking for that integration with other interested reed communities, other interested, forests or other land management agencies. How do we get out there? The need for, the local people to do some of their own evaluation and treatment effectiveness, that kind of thing. So looking forward to expanding this beyond what we've done, but these are our results so far. And please let me know if you have questions or if you want me to revisit any of the other slides. I'll just keep sharing until I hear that there's no more, no other slides that people want to look at.
Great. Thank you so much, Sarah. Excellent presentation. Very useful information. A lot to think about and perhaps review later as well. We have some interest in the chat for sure, of course, no surprise. I'm going to start out with a few kind of technical questions about your study that folks put in. Folks were curious about the slopes of the site, kind of if they both, kind of, can you speak to kind of what slope range you were looking at and how, when you're making comparisons between fires, you were accounting for variation in slope, or between control and treated, were you accounting for variations of slope? And I guess to follow up on that, for the water bars, generally the spacing is determined by slope. And so for your water bar treatments, was the spacing the same across grade as with the hand bars, for example, as the machine? And just any of those details, how do you control for that slope factor? Thank you.
Yeah, good questions. We're really picky when we select slopes, especially within a site, looking at the control slopes and the treated slopes. Our goal is 30 to 35% slopes. And I think probably the lowest we had on any of these plots was 25%, and the highest we had was just under 40%. So they're all within maybe a 10 or 15% difference. And we definitely make note of that. We use like a rangefinder for slopes. And then when we do statistics on these later, like I said, these are just kind of all preliminary data, but when we do statistics on them later, we will take slope into consideration. And then as far as the water bar spacing, we did, I think they were about 100 feet. So most of our silt fence plots, we looked at a 20 to 30 meter segment. So maybe 75 to 100 feet in length. And that was the contributing area into the silt fence. And then on those silt fence plots that had water bars, that was the contributing area for each of those water bars. We made use of the water bars, not just as a treatment to look at, but they also delineated our plots. So we didn't so much as consider water bar spacing from a treatment prescription, more like we wanted to look at a 20 to 30 meter long plot. And so we'll have a water bar installed here. Yeah, I hope that answers the question. And there was the same spacing with the machine water bars as there was with the hand dug water bars. Like all of our plots are really controlled in size, if you will.
I can see how that would be important with the distance between spill points. If you're not controlling for that, clearly you won't have anything that's comparable. So yeah, thank you for describing that for us. We had some interest in if you're going to continue, if you anticipate continuing research on this topic, and about if publications. Are you planning to publish this, or is there going to be a, or how about for practitioners, any sort of user guide coming out of this, or just scientific journal articles, or what's the future looking like for this study?
Yeah, yes to everything. We definitely have plans to revisit some of these sites this year. Hopefully we get a little bit more funding from FAM to continue this work. We will publish in scientific journals, and then if there is interest, we would be definitely willing to work with the resource advisor community for some sort of user guide and, maybe best management practices kind of things. You can see from what we have so far, it's like everything's pretty site specific, right? We didn't do a lot of replication of treatments across different sites. So we have 4 sites and maybe 4 treatment conditions. So, but once we start building up that database of, here's what excavator and hand water bars look like on 4 sites, or here's what a pocketing treatment looks like on 4 sites. I think that's when you could really develop that, some of those end user guidelines that would be useful.
Excellent. I'm glad to hear you guys are going to keep at it. And yeah, we have some support in the chat for a user guide for sure.
Okay, that's good to know.
We had a few comments about, chunking or pocketing, whatever you want to call it, but about other considerations besides just erosion control. I mean, clearly your study was focused on erosion control aspects, but I was curious if you had any thoughts to share. There was, about some of these other issues, such as the time it takes to put a treatment in, when you might want to slash or water bar versus pocketing as far as efficiency, kind of economics on the ground. And then also about soil productivity. So do you see any loss, or do you have any concerns about loss of soil productivity if you're churning topsoil with the deeper soils while you're making your chunks or pockets?
Good questions. Yeah, the one site where we did do the pocketing, I don't want to say we had to babysit the excavator operator, but it took a lot of time, even just to do those experimental lengths that we were looking at, right? So he only treated maybe 5 30-meter lengths with that pocketing, and it took multiple days to kind of get it to our prescription. So I can see that being maybe more of a limited use treatment, right? In an area where you really, rather than installing like a tank trap kind of situation to keep traffic off, you could, pocket at the bottom of one, above a road, maybe that kind of situation. or one of the pictures that you had shared with me, Luca, where they, were discouraging the off-trail traffic. It seemed like that treatment worked pretty well there. I have generally operated under the less additional soil disturbance is better. More of that gentle pulling in the berms. If you really need a water bar, put them as far apart as possible. I don't have a ton of experience with this pocketing treatment, but we've also looked at post-logging operations, skid trails. In California, they like to use a scarification treatment, where they're, the idea is to break up the soil, break up any fire-induced soil water repellency, increase the infiltration. And the results on those are really mixed. Like, does that additional soil just lead to more available soil to be transported off-site, or is it actually increasing the infiltration? So I personally don't love it as a treatment. I think it's created more soil disturbance than is probably necessary. And our local soil scientist, I think, would agree with me, like not really liking that turning of the soil, right? Like displacing that topsoil. In that berm pulling in site that we looked at, right? They were just kind of almost replacing the topsoil, right? The topsoil kind of got pushed to the berms and then they're putting that back. And you saw the pictures I shared, how that vegetation seemed to be coming back pretty nicely in that site. So my vote is for less disturbance, but I understand that there are situations when it might be necessary.
Awesome. I think that's a super helpful point, and it relates a little bit to here we get more questions coming in. It relates a little bit to some of these other questions about kind of the chunking how to do these methods. Let's see, one of those was about kind of the general spacing of pockets. Do you have any recommendation as far as what you guys did? You said you're 1 foot deep and kind of 2 to 3 feet wide. Is that kind of what you'd recommend for pockets, or does your research show that going deeper, going shallower? It sounds like maybe less is more. If you went 6 inches deep, you might still get the same effect. What are your thoughts on depth of pockets and spacing?
Yeah, it seemed like anything 6 inches to maybe a foot deep is as deep as we would need to go, would be my guess. On this site, I want to say the spacing. So we had in a 10-meter plot, like our real plots, we maybe had 3 or 4 pockets. So, every 5, 6 feet, something like that. So, and it was kind of an alternating situation going up the line. Yeah, it's hard for me to speak beyond my, this one site that we did, because like I said, the site where we did the pocketing treatment was also very close to the site where they said, we don't need water bars, right? So it's, they're not super highly erodible soils, a fairly mild rainfall regime. If they have high intensity rainfall, they're probably going to be fairly short duration. Yeah, I don't want to speak outside of what I've sampled so far, I guess.
Certainly, thanks. And we have a hand up from Jason Remshard. Jason, please come on and ask your question.
Hey, I was sort of thinking about it, but Cedar put the question in there, so it's sort of along those lines. When we do prescriptions for repairs, it's typically like the minimum that we can get away with, or whether we feel like we just need it, but it's usually tied to the repair or the damage, right? So if it's a giant dozer line, then it's probably going to take an excavator. But if it's a hand line, then you can usually do the repairs by hand. And so it seems sort of intuitive that the smaller hand repairs would be less impactful than the giant dozer excavator repairs. But I'm just wondering if you thought about that, like when you're trying to compare your effectiveness.
Yeah, we didn't actually intend to evaluate hand lines, or hand water bars. It was a site that we'd picked out. We said, yeah, this looks like a good one, put in water bars or whatever. And we came back and it was just a single site that had the hand water bars. So I think I've heard of the same thing you have. It's like you have to use a kind of the same level of tool that it was built with to do the repair. So, you know, that makes sense to me. It was pretty interesting though. Just, I think on some of the sites, a hand water bar, you know, just a little bit of breaking up the flow and directing it off the line. Unless you're really looking at a lot of rainfall or runoff, I think that might be a decent treatment in some areas. And then less soil disturbance that would come with that additional excavator traffic.
Awesome, thanks.
Awesome. So what I'm hearing a bit is, you know, kind of less is more a little bit, right? Like light touch, light as you can go. I think that relates to a question that David asked in here about how would you compare the chunking technique to the respreading of organics and topsoil? And so he's seen sites that have been chunked where it hasn't really naturalized very well over time. And that relates to some other concerns in the chat about, you know, issues related to cattle grazing or wild ungulates, you know, with a bunch of holes all over the line. But do you have any, I mean, you've been kind of talking to, but any other thoughts to share on kind of when, as a resource advisor, you see a sectional line, when you might choose to throw in some chunks or pockets versus when you just pull the berm and spread slash? Any kind of indicators that you would point us towards?
Yeah, I would say that the berm and the slash scattering, like that is a more, you could use that as more of a ubiquitous treatment, and maybe the pocketing is more of a targeted prescription, right? Like if you're looking to really reduce traffic in a section of the line, that might be the treatment to go with. But in terms of time and, you know, eventual restoration, I feel like that pocketing might just kind of be a mess if you're doing it for miles. Just my general take.
How about proximity to a water body? This is one spot I've seen folks move towards chunking if it's, you know, say it's right above a stream that supports an ESA salmonid, for example. Would that be another example of a spot you think that would be appropriate versus, or do you think the slash and berm, you know, pulling the berm is enough in a spot like that?
I think it, you know, maybe it depends on the amount of slash available, because we really saw similar results on that Island Creek fire where we had a lot of slash available, like small slash that had a lot of good ground contact. It reduced the runoff and sediment just as well, if not better, than the pocketing. And then it makes me a little bit nervous doing an intensive pocketing treatment right by a stream, because you've disturbed all that soil, right? And I'm not entirely sure that it does increase the infiltration. It might just have more soil that is immediately available for transport if you had a large runoff, high intensity rainfall situation. That's my gut feeling.
Awesome. And then we had let's see, any other folks want to ask Sarah a question direct here in the last chance to raise a hand before we break apart? I was just going to address one. One person asked if excavator operators are familiar with pocketing. I know Sarah mentioned that, you know, how much babysitting they did. And I'd say, yes, that's kind of generally you can expect if you're looking to do pocketing, chunking. The operator probably is never going to have heard it before, and you're going to have to do a lot of coaching and be with them there in person. That's been my experience for sure as well. Awesome. Well, thanks so much. And Sarah shared her email address if any questions come up here after the call. And thank you all for your attention. And thanks again, Sarah, for sharing this great work. We look forward to following it into the future. Turn it back to you, Pete.
Thank you for the opportunity. This is great to share.
Wow. LUCA, Sarah, MARISA, thank you all so much. Obviously, with the you know, the activity in the chat, a topic of great interest to us, and one that we'll stay tuned with, and glad that the work is ongoing and will continue. Again, Sarah, thanks for an excellent presentation and for handling all those questions kind of coming from all fields. LUCA, thanks for moderating that. MARISA, thanks for pinch hitting for Dave for leader's intent. I'll mention to everybody that our next call is June 17th. And our topic is somewhat related. This is, we'll be focusing on heavy equipment, timber harvesting equipment in particular, in work that we get involved with a fair amount. Shaded fuel breaks, reinforcement of using roads as lines. And so we've got a good presentation lined up in June. As I said at the beginning of the call, the recording will be posted on our READ cohort channel on YouTube. And Sarah's going to provide us her presentation to be put in our Google Drive reference library. Everybody, thanks. Hope you have a great day. I think we're going to try to have the READ cohort managers hang on for a couple minutes to compare calendars to try to set up a more detailed meeting, but really appreciate the almost 200 of us that were on the call today. And Sarah, again, thank you. Excellent presentation.
Thanks, Pete. Thanks, everyone.